Hello, today we're going to look at designing a column using ClearCalcs. So in a previous video we had finished designing a girder. We had used a W6 by 20 steel girder. Now we want to design a post to support this girder. So let's add a new calculation. We're in the US standard. And we're going to make a wood column, ASD, and we're going to have an interior isolated column. What we're saying with this is we're basically going to have a post inside our building. So while this gets loaded, we can turn off the details where you can see all the assumptions that we make with the design. And the first thing to look at is our column height. So in this case, we have 12 feet. That might be a little high. You can see this is based off the project default on the story height that you set. In this case, let's get it down to 8 feet, or we can say 9 feet, or slightly higher ceiling. One thing that we ask you is for the continuous bracing. Since it's an isolated post, we don't have to look at that. So we're going to go all the way down. We're going to look at our loads. You can see we've got some default loads here. In this case, though, it's only supporting the girder, so we can delete these loads and we can create a new load. And we're going to add beam 2, which was our girder, and we have our reactions. In this case, they're the same at both ends, so we'll just pick the first one. And we want to add this at the end of our beam, so we can just type L, and that adds our beam at the end. So you can see here we've got our reaction here, and one thing to notice here is we've got an eccentricity of, in this case, d over 6. So that's the depth of our column over 6. It's common practice to have a slight eccentricity just to account for connections or if things aren't set perfectly straight in the field. So with that done, we can go back up. We can see that we've got an 8 by 8 Douglas fir column, and it's way bigger than it needs to be. So let's use the member selector to see what we can find. So we're sticking to the post and timber grades, since these are the ones that would typically be in the range we estimate. If we're going to stick with Douglas fir, we can see that we can get pretty small. A 5 by 5 Douglas fir number 2 is 99%. If we use number 2 dense, we're a little higher, but we can stick with number 2. That's easy to find. And you'll see that what governs is the interaction. So that means that it's the combination of the bending from the eccentric load and the compression from the actual weight of the girder that's causing the most critical thing. So with that, we've got our 99%. We've got our column at the right height with the right loads, and we can say that we've designed our column.